Welcome to ZT classes.
See the next question. So we have a window of a house is h meter above the ground. So let's draw the ground and then the building with window W. Right? From this window the angles of elevation and depression of top and bottom of another house is found to be alpha and beta. So let's draw the other house. So that other house is OQ, and the angle of elevation and depression, for that we need line of sight. So observer is at W, and let's draw the line of sight. From here the angle of elevation is alpha, so this angle is alpha, and angle of depression to the bottom, that's beta. You have to prove that the height of house is h times 1 plus tan alpha cot beta, or basically you have to find the height of the house, or QO. QO is what you have to find. But here if you will see, MO is same as WB, so MO is also h meters, or in one word you have to find QM and then you add h into it to get the height of house. Let's see the solution. So here in this question, given is the height of smaller house is WB and the other house is represented by OQ. W is point of observation, that's the window of smaller building, and QWM, that's angle of elevation, is given as alpha, and angle MWO, that's given as beta. We have to prove the height of house, that is QO, that full house is h times 1 plus tan alpha cot beta. And let's see the proof of this. So here if you will see, again we have got two triangles are there, right? The two triangles are your WQM and WMO. These are the two right angle triangles are there, so in which you will use trigonometric identity, and WM is common in both of them. So using this triangle first, we'll find out what is the value of WM in terms of h and beta. Once we have got WM with us, so we'll use this triangle and we'll get the value of QM in terms of alpha and WM. So once you have got QM, we'll add h into it to get the value of QO. So let's take the triangle WMO first. So in triangle WMO, tan beta is perpendicular upon base, or MO upon WM, and putting MO as h, we get tan beta is h upon WM, and from here we'll get the value of WM as h upon tan beta. Now this value of WM we'll use in this second triangle. So in triangle WMQ, let's take tan beta, that's perpendicular upon base. QM is what we have to find, so let's take QM is WM times tan alpha. Now this value of WM we will put here, and we'll get QM is h upon tan beta into tan alpha, right? 1 upon tan beta is cot beta, so basically QM is h times cot beta tan alpha. But we don't have to find QM, right? We have to find value of full QO, or the building. So the value of QO is MO plus QM, and MO is h, QM we have just found. So adding these two, we'll get our result, that is the height of the building is h times 1 plus tan alpha cot beta, and that's what we had to prove, and hence proved. I hope you enjoyed the solution. Keep watching.